Good afternoon and welcome to the second concurrent session of the day, Experiments, Student Achievement, Engagement, and Diversity in the Economics Classroom. Our presenter today is Dr. Tisha Emerson from Baylor University. Dr. Tisha Emerson is a professor of economics and holder of the Ben H. Williams Professorship in Economics at Baylor University. Dr. Emerson is co-editor for the Southern Economic Journal and on the editorial board for the International Review of Economics Education and serves on the AP Macroeconomics Development Committee. From 2009 to 2016, she served on the Committee on Economic Education of the American Economic Association, including serving on the Program Committee for the Conference on Teaching and Research in Economic Education, CTRE, and chairing the Program Committee for the 2013 CTRE. She also served as an associate editor for the Journal of Economic Education from 2011 to 2017, and was awarded the Kenneth G. Elzinga Distinguished Teaching Award by the Southern Economic Association. Dr. Emerson lives in Waco, Texas with her daughter, Sarah, who is a tennis player and an aspiring marine biologist. If you have any questions for the presenter during the session, please feel free to enter those into the Q&A section at the bottom of the Zoom room screen, and we will address them at the end of the talk. On that note, I will hand it over to our presenter.
Well, hi, everyone. I'm so glad to be here. It's such an honor to be asked to talk to you about something that I truly love, which is classroom experiments. So let's go ahead and get started. Let's see. There we go. So what are the objectives for this particular session? Well, first, I'm going to identify what a classroom experiment is. I'd like you all to have an understanding of how the case for interactive learning applies to classroom experiments and how these classroom experiments can promote diversity in the economics classroom. You'll also have an opportunity to participate in an experiment. This is going to be something a little bit new for me. I'm not entirely sure how well this is going to work in this setting, but I could not possibly give a talk about experiments and not have you have the opportunity to participate in one. So hopefully technology will be our friend today and that will work okay. We'll review some options for debriefing the experiment, and then finally, we'll consider a number of logistical issues. So if you decide you want to actually adopt classroom experiments, so what are some of the things that you should consider? And then also I'll provide you with some sources of classroom experiments. So first, what is a classroom experiment? Well, it's basically an activity that asks students to make economic decisions. So it puts them in roles of, say, buyers or sellers, and potentially as producers. And through making the decisions in these roles, they're going to be creating data. So for example, if we have students some are buyers and some are sellers, they're negotiating prices, that those prices will be part of the data that we could collect from the experiment. We'll also be keeping track of how many trades there are, so what quantity of the good is traded. All of this, as well as knowing about some additional information about the buyers and sellers, will also allow us to figure out things like consumer and producer surplus. So all of these things will help students to better understand the economic concepts that we're presenting in our classrooms. And of course, this is active learning, so they're actively engaged. A lot of times, I think the last survey still had us at 80% or more of economics classrooms were using what we call a chalk and talk approach. So students would sit there passively while the information is presented to them by their instructor. But classroom experiments are really not that. The students are getting up, they're actively moving and engaging with the material, with their classmates, with their instructor, and this will give us a number of benefits. So sorry, I'm having trouble with my mouse there. Okay. So why? What are these benefits? Okay, so I think the most important thing that we're all concerned about is, our students, what's going to be the effect on students' learning? And the evidence very strongly suggests that there is higher student achievement and learning when students are exposed to a pedagogy that uses classroom experiments than to one where there's just simply, sort of chalk and talk. So the professor just presenting the material. When the students are engaging in the classroom experiments, we see that the achievement is much higher for these students. So that could be in terms of student grades at the end of the semester, performance on exams, but also we have before, so at the beginning of the semester, students might take an exam, take the same exam at the end. And so we can measure how much they've learned, right, over the course of the term. And all of these measures are tending to suggest that students are doing better when they are participating in classroom experiments. Now, there's also some evidence that females may disproportionately benefit from the use of experiments. So that's not to suggest that the males are harmed, but instead that females kind of get like this extra boost. Now, this is going to be really important because we also know from the literature that females tend to underperform males, all else equal, in economics. So we call that the gender gap. That is problematic for us if we really want to promote diversity in economics. We know that only about 1 in 3 majors, economic majors, are female, and this has been fairly consistent for decades now. And this is even as we have more and more of the overall degrees being awarded to females. So we have an increasing female population, but we don't have increasing female representation in our majors. Now, why is that? There are a lot of things that people have hypothesized, but one of the things is that we do know that females are much more sensitive to grade signals than our males. So, for example, a female who maybe gets a B in principles of economics, all else equal, is going to be much less likely to persist and take additional courses in economics than a male who gets the same grade, a B. And so to the extent that the classroom experiments make up at least a portion or even completely makes up the gender gap in performance, that could move us towards having females performing better and maybe increase their likelihood of persisting and hopefully sort of move that dial on the diversity, the gender diversity in our discipline. We also see that there's a lot more engagement and involvement by students. So of course, during the experiment, they are actively involved. They are thinking about, what is the best thing for me to do? If I'm a buyer and I have this information, what price would I want to buy at? If you're a seller, what price do I want to sell at? And so the students are actively involved in making decisions. They also are either involved with their classmates through a computer interface, or, when we kind of get back to normal and we're face-to-face, in my classes, normally they're negotiating face-to-face. And so there's this added level of involvement. There's a lot more excitement in the classroom because it just builds this energy that, participation in the experiments does. And then that follows on to after the discussion, after the experiment, because we then discuss what happened in the experiment. We call that a debrief. So the students sometimes, if I'm not using experiments, we're just kind of covering a topic and maybe I'll ask a question and students will just kind of sit there, or maybe they'll say, I don't know, but they always have something to share after the experiment. I say, well, who were the buyers in here? And they can raise their hands and I'll call on one of them. And I always try to go around and, ask different people questions and get them involved. Well, what did you do in the experiment? If you were a buyer, were you able to purchase a unit of the good? If so, what price did you pay? Was it difficult for you to find a trade, right? You can have all of these questions. You can pose all these questions to the students and they have answers. They just participated in this. But also they're much more likely to want to discuss it. And so all of this makes for a much more engaging environment in your classroom, which honestly spills over even onto the days where you're not doing an experiment, because I don't do experiments every single day. But it builds this community in the classroom, and it's much more of a sort of safe and welcoming environment. And so even on days when you don't have experiments, the students are going to be more likely to be involved and engaged and be willing to share. And then they're fun. My students love them. Regularly, they come to class on experiments days and they're like, oh yes, and it's an experiment day. I'm so excited. And they love it. And of course, I really enjoy it because I love having that energy in my classroom. They will tell me I've had students say, I told my parents about the experiment and I was sharing what we learned. So it's not just I was sharing, the excitement and the energy and I had a good time, but they're sharing what they learned. They also have told me I was telling my roommates about this and my friends. And so I really do have a sense, not sort of, I guess, both anecdotally, so my own, experience, but also from the research that there is really a sense of community that's built and excitement and engagement for the students. Okay, so I think we should experience an experiment ourselves. So we're going to participate in a short competitive market experiment where each of you will be assigned a role, and it's going to be in the apple market. So we're going to be trading apples. Some of you will be assigned the role of a buyer. And if you are a buyer, you'll get some information on your screen telling you you're a buyer and what your buyer value is. So your buyer value is the value that you place on a unit of apples. You'll also see on the screen that your profit, or your surplus will be the difference between your buyer value and the price that you agreed to pay. So the buyer value minus the price is going to be, of course, your surplus. Others of you will be given information that you're a seller. And if you're told you're a seller, you'll also be told what your seller cost is. This is going to be the cost to you of producing and selling a unit of apples. You will only experience this cost if you actually make a trade. So you don't experience the cost until you have committed to making a trade. That's going to be important. And your surplus will be the difference between the price that you get paid and the seller cost. So the price minus the seller cost will be your surplus. So the instructions will be displayed on the screen. And I'm going to go ahead and give you those instructions of how to get logged in. And let's see, I'm going to have to make that a little bit smaller so I can also go to my other screen. So what I would like you all to do, and you could do this either on a cell phone or you could do this in one of the windows on your computer, is go to this URL. And then you're going to see 3 drop-down menus. On the first, you're actually going to have to scroll really pretty far down because it's listed by university, but within each country. So go all the way down to where it says United States and then Baylor University. The next drop-down menu, you're going to want to select classroom experiments. And then the final one, you're going to select participant. And then it's going to ask you for a password. And the password is just 12345. So I'm going to give everyone just a minute to get logged in. And I see that we're starting to have people getting logged in. But I want to give everyone a chance to get logged in who wants to participate before I start us. So we'll just take a second. And if there are any questions, feel free to put it in the chat and I will see. I will be happy to answer any questions that anyone might have. So maybe while we're waiting for folks to get logged in, I'm going to just mention a few things. So this platform is called ClassX, and it's coming out of Europe, but they're working with Ted Bergstrom and John Miller. Ted and John had a textbook that they published, I think around 2000, that had about 15 experiments that you could run, and it was all manually run experiments. So now what this website does is it is computerizing these various experiments. And they're still in the process, so they don't have them all 15 of them there, but they're working to computerize those experiments. And this is really, I really like this because it's free and, we don't necessarily want to be adding additional cost to our students, but also it can be run either on a laptop. So your students could use laptops, or your students could just use their smartphone. And not all the platforms allow you to do that. MobLab, which is another option I'll talk about a little bit more later. MobLab does also allow students to participate on their cell phones. That is the platform I used last fall. And I did find that it was about equally mixed. About half of my students would bring their laptop when they didn't normally. but they would bring it on experiment days. And then the other half seemed to either use like a tablet or their smartphone. But MobLab is there's a fee for that service. And also what hopefully you can see is that it's pretty quick to get set up. There's no sort of pre-registration required with Class X. So you could just kind of decide, okay, we're going to go in today, give your students this information. They also have a QR code, which you could use instead. I just decided to do it this way, but they have 3 really simple ways for your students to just go ahead and get logged in. So it's really, really fast to get started. It's a little bit more work to get started with MobLab, but not a ton. The other option for Computerized is the Econ Lab. That's also a free service, and it's also fairly quick to get started. So what I'm going to do is, I think we maybe have all the people who are going to get logged in. So I'm just going to go ahead and start. And you should then be getting the information as to what your role is. And again, if you're a buyer, it tells you your buyer value, and you're going to have the opportunity to put in the price that you would be willing to buy a unit of apples at. If you're a seller, it tells you your seller cost, and you can enter the cost that you, the price that you're willing to sell a unit of apples for. And then you also will then see the offers and asks that other people are making, and you can go in and select one that you might like to accept. You also see a little withdrawal where if you decide, oh, I want to withdraw maybe the offer that I made and put in a different offer, you can withdraw it and then change your offer or your ask. So we have had our first transaction. Now we have our second. And I'm just going to give it maybe another minute or so to see if we have any other transactions, and then we'll do a quick debrief. And then also what's nice about this is you could potentially project what's happening. Now, I don't actually have it up, but let me change my screen. I'm going to share a different screen with you so you can see what's happening now. So you can see here that we know that there are the 2 trades and the prices for the trades. So there was one unit that was traded for $11 and one for $15. And now we have a third that was for $36. And I think we might just have buyers left. So let's go ahead and stop. So you would have this period where the students are trading, and then you can stop what's happening. So now I'm going to the feedback, and what we can see are the different types that were assigned. So we had a couple of people who were assigned type A. Type A, was, I believe type A is a buyer, and it has a certain buyer value. And we see so all the different types. You can see what actually happened in the experiment. So you see that what time the trades took place, the buyer values for those trades, the seller costs for those trades, and the prices that the trades took place at. And then, of course, we know from looking at this that there were 3 total trades that occurred. You can also reveal what happened graphically. So this is another way to present the information to your students. And this is all auto-generated by Class X. There's something similar in the other computerized platforms. Now, if you're doing a hand-run experiment, you would be manually having to create all of this, but often that is how I do it, and it's really not terribly onerous. You can also look at the averages. So we had a median price of $15, a minimum of 11, a maximum of 36, and we had the average price was $20.67. So we know we had 3 units traded at an average price of just under $21. Then we can look at this screen, which shows us the prediction. So for session one, which is what we did, we see that this orange curve here shows us the demand for apples given the buyers and the buyer values that we had. The blue shows us our supply curve given the seller cost and the number of sellers that we had. And you see that the predicted outcome is 2 and that the price would be somewhere between $20 and $30. So we're at the lower end of the price range and we're just above the quantity. Now, you won't necessarily get exactly to the predicted outcome with just one round of trading. And so we're a little bit off. Honestly, we're not that far off. But generally, I do 2 or 3 rounds of trading, sometimes a little bit more because it's actually a lot easier to do more when you have computerized. So sometimes I'll even do 5 rounds of trading. And you get incredibly close to these predicted outcomes. Of course, then you can also predict the consumer and producer surplus and compare that to the actual consumer and producer surplus that's realized. So let me now go back to my other screen. And I see a question. So there's a question. How many students do you normally have in an experiment and how long do you let the experiment run normally? So normally what I do, and it's usually I say there's a whole day for the experiment. So we do this competitive market experiment. We will take an entire class day. I have 75-minute classes. For the manually run ones, I'll usually do 3 what I call sessions. So the demand or supply might change a little bit from one session to another. And I'll do maybe 2 or 3 rounds of trading within each session. So maybe a maximum of maybe 9 rounds of trading. Each of them take about 3 minutes when they're manually run. And then I have time for the debrief in the 75-minute class. For the computerized, like I said, easily, I could run 5 in each session, and those just go really quick. And so I could do, again, 3 sessions, but each of them might have 5 or more rounds within the session. And I have had lots of variation in the number of students. So this fall, I had about 40 in each of my classes. I've had as many as 60, maybe 65, where I've done manually run. And then I've had classes that are really quite small, like during summer session where I think I had 10. And I was a little concerned because I thought, I was doing manually run experiments and the market might be a little bit thin, but we hit the predicted outcomes every time. It was really pretty. It was pretty incredible. But what you can do with some of these computerized platforms is you can have robots participate as well. And so you have a thicker market that way. Okay, let's see, there's another question. Do I provide their value and cost before the experiment? No, it's just like what you saw where you got it from the computer at that point. Or if it's manually run, when they come in that day, I just hand out the sheets that tell them basically the same kind of information you just saw on your screen, and they get it at that point. I do provide the instructions beforehand, so they have an idea of what's going to happen, but they don't know their particular role. And I'll circle back to that a little bit later in the logistics part. Okay, so we got you logged in, and let's go to the next slide. Oops. So what can students learn from the competitive market experiment? Well, as you saw, they can see how to predict the equilibrium outcomes in markets. So again, you can give them the distribution of buyer values and seller costs and draw the demand and supply diagrams. Also talk to them about surplus and how to predict the surplus, but also compare it to calculating the actual surplus, the actual price and quantity that we saw in our data. And my students, they seem to really then get the predictive power of just these simple models that we're using. And I actually, just this last fall, as we were going through the debrief and we were comparing the predicted and the actual outcomes, and they were so similar. And one of my students out loud said, "Oh my gosh, that's so cool." And it is, because it's like they see that they're just participating in a market and we could have predicted the outcome before they even started. So I love it. You can also do extensions though. So this simple competitive market experiment, you can add a price control, you could add a tax, and those are really helpful. I generally run the competitive market 1 week. So just before I start demand and supply, then I talk a bit about demand and supply. And then just before I do price controls, I will do usually a minimum wage experiment. Students really love that one, to illustrate price controls. But you could just go back to the Apple market and add a price control. And there you could do both a price ceiling and a price floor, in separate treatments. And I think the students really gain a lot from that. And then this also could be a launch pad to more. And I really would suggest that there would be more beyond the debrief in class. So for example, you want to have them do some sort of homework, right? Where they're looking again themselves at predicting the outcome and also calculating the actual outcome and comparing them. So comparing the theoretical and the experimental outcomes. So what you can do, if you do maybe 2 or 3 sessions where maybe session 1, you have some demand and supply like we just did. In the next session, you could change the supply a little bit, run that again. So what you do in your debrief in class is you do the full debrief, basically what they would do for homework. So drawing the demand and supply, calculating the average price, comparing that average price to the predicted from our demand and supply diagram, right? You do the full analysis for session 1. And then for homework, they do it for session 2. So they've seen it and they kind of have a sense of how to do it, but they're really doing it for different market conditions. And I think that's extremely helpful. There is also research that suggests that students only really learn from the experiments if they're doing some sort of follow-on exercise. Also, students could maybe complete additional readings, especially if you're doing maybe price controls or something else, right? So additional readings, maybe something that brings current events into the classroom and ties it to the experiment. And if you have maybe a writing intensive class, you could have students write an essay to discuss the effects of price controls or taxes or whatever you might have from your experiment. So that brings me to some logistical issues. One thing I think that's even more important that we think about these days are the trade-offs between computerized and hand-run experiments. For a long time, there really were just kind of the hand-run and there weren't as many computerized options, but there are a lot more options now. As I mentioned, there's ClassX, which we used, which is a free open access resource. There's also VEcon Lab, which is free. They both have a number of experiments, interesting variety, and your students and you and your students, no one has to pay for it. There also, though, is MobLab, which is a fee service. It does maybe look, so the visuals are a little bit slicker looking. They have videos that have instructions that you can show for the students. So there's that. But I've actually used all 3 of them. They're all really quite good. And so there are these nice options to do the computerized or to do the hand run. Now the hand run, I think obviously a lot of us are not face-to-face, so hand run's not an option, but I would really recommend that you kind of keep that in mind going forward as we move back to some semblance of more normalcy and are back in the classroom. What I would say, like for myself, what I have decided is that for a very long time, I've used exclusively hand-run experiments. I love them. I love the energy in my classroom when we run them, because it's basically your classroom ends up looking like the floor of the New York Stock Exchange. And the students love it. And I really think that's a great atmosphere for building community. But when I was forced this fall to go back and use computerized experiments again, I used MobLab, and the students really seem to enjoy those too. I also have done a study that showed that there was no difference in student learning between the computerized and the manually run. So that, I don't think you need to worry about student achievement and learning being different between the two. But I do feel there's a little bit of a difference in the extent to which you can build community in the classroom between the computerized and the manually run. But what I'm going to do is I'm going to use a mix. once I go back and we're face-to-face, I intend to continue to use some computerized experiments, because one of the nice things about that is you can run them outside of class time, especially with these platforms that allow you to have basically robots play with the students. So you can do it asynchronously, and that can save you some class time. I was running out of time in the fall, and so I ran, I think, 2 or 3 of my experiments outside of class time. Just did it asynchronously, and then when we had our next class, we did a debrief then, and I think that worked really well. But I did kind of miss the extent to which we could have had community built up from the hand-run experiments. So my solution going forward is a mix so that I can have the best of both worlds. How much class time? We already kind of addressed that a little bit. Really, most of these experiments, especially kind of the competitive market ones, or if you're doing like a monopoly or maybe an oligopoly experiment, some of those, they will run you your entire 50-minute class. 75-minute class, you can also do the debrief. Other experiments, like if you're doing just a public goods experiment or maybe a bank run experiment, those, including the debrief, that only took me about half of my class period. So really, some of them can be much quicker. Do you do it during class or outside of class time? I really like the idea that they're interacting with each other. So I like for them to engage in synchronous play. So except for the 2 or 3 that I did outside of class time, I always do it during class so that they can interact with each other in the class, even if it's moderated through a computer. And also, there's usually a chat feature with a lot of these platforms, so the students can chat with each other. Now, again, if you're really kind of tight for time outside of class time, doing some of them that way, I think is absolutely fine. Are there class size limits? To some extent, yes. Certainly with the hand run, if you have 100 people in your class, you're not really going to be able to do a hand run experiment. But the good news is you can do computerized experiments with very large classes, and so still have that experience for your students. For smaller classes, like I said, you might be worried that maybe some of your classes might be a little bit too small to have a thick enough market. I certainly have been worried about that, but that's not been a problem. But if you are really concerned, if you use computerized and augment your class with robots, then you can have a thicker market. Does everyone participate? So this is one of the times where it's not, well, there's these trade-offs, and on one hand, the other hand, no. Yes, everyone should participate. I think this is incredibly important. Before computerized experiments really became an option for a lot of people, instructors who had very large classes who really couldn't run a manually run experiment with, say, 200 students, they sometimes would have just a few of their students participate and everybody else observe. The evidence suggests that that's not going to be very effective. So I really would implore you to have everybody have the opportunity to participate. You get much less from simply observing than participating. And then how many experiments? So one of my studies was looking at this, and we looked at anywhere from a small number of, say, 4 experiments to a large of 11 throughout the course of Principles of Microeconomics class. And we found that sort of the optimal number was somewhere between 5 and 7. And so that's usually the number of experiments that I do, that there wasn't much value added beyond the 7th. And when I say that, I'm really thinking about the experiments kind of adding to their understanding and having these positive spillovers. So yes, maybe you'll do a competitive market experiment. There might be another topic, say comparative advantage, where you don't do an experiment, but there's this positive spillover to student learning as a result of engaging in a pedagogy of experiments in the first place. So you get these benefits even for topics where you're not explicitly doing an experiment. Again, though, kind of caps out at about 7 experiments. So you really, if you wanted to adopt this pedagogy, maybe say in your principles class, I would really suggest doing somewhere between 5 and 7. I usually do 6 or 7 experiments. Which and how many experiments should you use? So which ones? I think you want to pick topics that you think maybe students have a little bit more difficulty with, but also that they're really good experiments for those. Um, I always do, like I said, competitive market. I have not really found a comparative advantage experiment that I really like, so I don't tend to do that. I do other activities for trade and comparative advantage. Um, there's this great airplane experiment for production. And I didn't get to do it last semester because there's not like a computerized version. But whenever I'm face to face and my students get to interact with each other, I always do that because it really gets them to understand diminishing returns. So I'd be happy if anyone has any questions, wants some tips on some of the better experiments from my experience, I'd be happy to go over that with you. All right, what background should the students have before the experiment? This is crucially important. You really want them to have the instructions. So I always provide them either with written instructions or with Mob Lab last semester, they had videos, instruction videos. So I always sent my students the link a few days before we had the experiment and asked them to watch it. But then when they get to class, I review the instructions, we watch the videos together. And what I often do is I say, hey, the first time I looked at this or the first time I participated in this experiment, these were things that were confusing to me. And so I just want to make sure you all understand that. And maybe you have other questions. So please ask them if you do. And kind of having that discussion with them really helps. That's all I do. I never talk about the concepts themselves because it is through the experiment that they discover those concepts, the experiment, and then the debrief. So you don't want to present, demand and supply and then do the competitive market experiment. It's always do the experiment, help them realize what's happening themselves, then, talk about the actual theory from the textbook. A few more logistical issues. How do you make sure that your students understand the experiment and their role? Well, I ask them questions and I say, okay, so who are the buyers? And everybody raises their hand and, just lots of questioning them, going over the instructions, maybe a little bit more than you think is necessary, especially for the first couple of experiments. I take a lot more time with the instructions at the very beginning of the semester. And then I tend to use experiments that have similar setup. So after they've participated in the competitive market experiment and then a price control experiment, a lot of the other experiments run in a similar way. And so instruction and all of that at the beginning of the class is cut probably to, I don't know, it's less than a third of the time that I take at the very beginning. So it ends up becoming very quick. How do you motivate your students? Oh, sorry, there's a question. Let me address that question real quick. Yes, Class X is free. Okay, so how do you motivate participation? This is something that is still really pretty hotly debated. And what I do is I use extra credit, and the extra credit is tied to how well the students do, so their surplus in the experiments throughout the semester. So I basically keep track of, I call it their earnings, but it's their surplus or some measure of earnings for every experiment that we have. So maybe say 7, and I have their total earnings or surplus at the end of the semester. And I have also the total earnings for the entire class. So then I calculate the fraction of the total earnings that each student actually earned. And then I have a pool of extra credit points, and they get the same fraction of the pool of extra credit points that they had of the earnings. And it's fairly easy to kind of adjust that so that you can expect about how much the students are going to have. I do it this way, and I think it's really kind of important because I have, let's say, 7 experiments. In one experiment, you could have, sort of an unlucky draw. Let's say in the experiment that we just had, there were sellers that had $10 seller cost, and there were sellers that had $30 seller cost. It was not a good draw if you got a $30 seller cost. You were in a much worse position to earn surplus than someone who had a $10 seller cost. But over the course of 7 experiments, that kind of evens out more. And so I feel really pretty comfortable about this approach. Not comfortable enough to make it a grade. It's just extra credit. But there are there are papers out there that suggest that having it be part of the student's grade is helpful. Of course, other people talk about actually paying the students. And my institution would not go for that. But also, I don't know that a lot of us are at institutions that have the funds to just kind of pay that, even if you give them just a fraction of their earnings. But I have not had any problem using extra credit. It's always been sufficient motivation, and I think pretty fair. Okay, so what sort of data should you collect and how? So you saw, of course, in the experiment that we did, that the computer just does it all for you. It keeps track of who trades and what their buyer value and seller costs were, the price that's traded at. You even have this time data, so you can see which trades happened early and which happened later. All of these things you can discuss with your students. If you are doing this manually, you have to keep track of that yourself. I just have an Excel spreadsheet, and the students fill out a transaction form that has that same data. So the buyer value, the seller cost, the price that they traded at. And I just enter it into the spreadsheet and have a few formulas in there so that it automatically calculates average price and stuff for me. But those are the types of things that you would want to collect. And again, if you use a computerized platform, that it does it all for you. And I think you've sort of seen some of the analysis that's possible. If you're doing that airplane experiment that I talked about, you keep track of basically the students are, they're put into firms. They start with certain fixed factors, and the factor that you're changing is the number of workers. And so you just keep track of how many paper airplanes they're able to produce per period and how many workers were at the firm in each period. And then you can calculate marginal product of labor, and then they see the diminishing product. So all kinds of analysis is really quite doable. What role should the instructor play? Now, it's pretty important that the instructor just kind of presents this is the activity, these are the instructions, you answer any questions the students have, but do not direct them in a way like, oh, gee, those prices are really low, or anything like that, because then it makes it seem like you're kind of the puppeteer, and then they become suspect that really, the professor's really just driving the outcome. It's not happening naturally. And really it does. So you need to be very careful not to kind of overstep. You're just presenting the activity, making sure everybody understands their role, what the instructions, what the rules are, and you go from there. Otherwise, you're really going to undermine the student learning and their belief really in the value of the activity and the theory. Okay, so let me now just show you a few sources of experiments. The computerized I already mentioned. So there's MobLab, that is a fee service. But again, if you have a Cengage textbook and you use MindTap, which is their I guess their interactive system where you can have computerized homework and stuff. So again, it's Cengage. If you use a Cengage textbook and you use MindTap, you already have access to the MobLab experiments, whether you're using them or not. So there would be no additional fee for anyone who's in that situation. The other two computerized options, they're completely free. They're not tied to any textbook or anything. And they're VEconLab and ClassX. And again, what we used was ClassX. And then for hand run, there are lots of sources. My personal favorite is the Bergstrom and Miller Instructor's Manual for experiments with economic principles. And you can get the PDF of the manual, which has instructions for the experiments, all of the handouts that you would need for the experiments. All of that is in the instructor handbook, and you can get a PDF of that at this site, at Ted Bergstrom's site. Also, Charlie Holt, he's the developer of VEconLab, but he also has a number of experiments, papers presenting his experiments that you can do manually run. The papers include instructions. They give you whatever handouts you might need. They talk you through like a debrief. So what are some questions you might ask students as part of the debrief? All of that are in all of those papers that Charlie has on his site. And then also there are other people who have published articles that present classroom experiments. And you can find a lot of them published either in the Journal of Economic Education or the Southern Economic Journal. And I've used all of these. I've used Charlie's, I've used Ted's, I've used all the computerized platforms, and I've also pulled some from the journals. So they're all really good sources. And then finally, I just want to reiterate that it's really interactive learning is really important, not just for student learning, but it's important to the extent that we want to promote diversity. So Bear et al., they go through, what are going to be important factors for fostering diversity and persistence of students, especially students from previously underrepresented groups like females and URM. And they talk about the importance of relevance, belonging, and mindset. Relevance refers to, you need to make what you're teaching relevant to the students. And as the students participate in the experiments and they see, oh, I'm a buyer. I'm a buyer every time I go to the grocery store. And they're able to see how all of these things we're talking about, like it can apply to their everyday life. So it really develops that relevance. Through the interaction and the increased level of discussion, it promotes community in the classroom, which is very, very important for fostering belonging. And then finally, growth mindset. As I mentioned, through the experiment and then the subsequent debrief of the experiment, the students are able to they discover a lot of the concepts themselves. So you as the instructor aren't necessarily presenting all of these ideas to them. They're discovering them as they go through the experiment and they think through the debrief. And that really promotes a growth mindset, because what we mean by growth mindset is showing the students that there's not some fixed set of aptitude or competency that you have in economics, but really that it is a malleable thing that it can grow, it can develop, they can learn more, and they can become more competent in economics than maybe they thought they were able to before. So I really do think that experiments, not only are they super fun, students are going to love them, you're going to love them, leads to higher learning, but I do think it is one of the factors that could contribute to increasing diversity in our discipline. So if there are any other questions, please feel free to put them in the Q&A, but also feel free to reach out to me. My email is on here. I'm happy to field any questions y'all might have.
Yes, thank you, Tisha, for that informative and interactive session.
And
I
I
know
went
I
too long, I'm
personally,
sorry.
no, I learned a lot, and I think everyone else did as well. Everyone, for the most part, is still in here, so you've kept them. For those who are still in here, I'm going to launch a poll real quickly before you head out, if you don't mind just sharing your feedback. Give me just a second to get that pulled up. And if there are any other questions, feel free to add those into the Q&A. We had someone who said thank you. And I'll give you guys just a minute to fill out that poll. While you are completing the poll or sending any last minute questions in, I just wanted to mention that Nelson Lauver is our next keynote speaker. He will start at 1 p.m. Eastern time. You can view the chat room for a link to access his session. And don't forget, while accessing our conference website, you can swing by our exhibit hall to say hello to the Hawks team. You can view a quick 5-minute demonstration, and you can be entered to win our hourly giveaway, which includes your choice of a smart pen, standing desk, or $100 Amazon gift card. So let's see if there's any questions before we go. I don't see any right now. I think you answered them all throughout the session. So thank you very much again.
Sure.
All right. Have a great day.
You too.